Question 6. The diagram below is a sketch of the Eiffel Tower. The sketch is drawn to scale, so you're going to need your rulers. The Eiffel Tower is 324 meters tall. Viewers can climb up to the level 2 viewing platform using the internal stairs. So you're going to need to get your ruler. I obviously can't show you on here because I don't have a ruler. It's on my iPad. It's not on a piece of paper. If I zoom in, zoom out, it's obviously going to be different measurements. So the answer is 650. Next one. So this looks like trigonometry. Calculate angle of elevation. So you want this angle here. I'm just going to label that X. You can keep it called it P if you want to, whatever you want. So because we're working with angles and lengths on a triangle, we've got SOHCAHTOA. So label the two sides that I've got. So this one, 324, is opposite to the angle. 800 is next to, which means adjacent to my angle. So I've got O and A, which is TOA. So my ratio tan of the angle X is O over A. So tan of my angle, which I don't have, so I'm going to keep that as X, which is O, which I do have, is 324, over A, which I also have, which is 800. So when I'm trying to find an angle, I want to shift. So I want to shift and then press my tan button and look like that. Of 324 over 800. Close my bracket and I get 22 degrees. So that angle is 22 degrees. Question 7. I don't even need to read it. I can see those are histograms because the bars are different widths and they're next to each other. It is a histogram. So Danielle is studying the growth of the population of Wales. She uses the 2001 and 2011 census data to draw these histograms, as I said. Now, before I even look over the next page and look at the question, the first thing you should do on histograms is just find the area of each of the bars, because that gives you your frequency. On the side is plotted frequency density. You want to calculate your frequency of all the boxes first. So to find out how many people are aged 0 to 20, then 20 to 30, etc. So the area of a rectangle is obviously base times height. So this base is 20 and that goes up to 37,000. So you want to times those, which is 74 or 740, sorry. Pen's being very slow. And next one, so that goes up to, these are just 10s, so 3, 4, 0, 0, 0, 0. Then 410. So I'm not even reading my question. I'm doing this to save me time. Makes the other questions easier. And that goes up to 39. Then this one's 300. And this one goes up to 17, so 3, 4. So this will save me lots of time when I do my questions. Probably might not even need all the numbers, but it is good to know. They might ask you how many what's the total population, which you would just add them all up. So this gives us our frequency. Oh my pen is not working. It's been really slow, like I've already wrote the number and it's still writing. Oh my god. Don't know if it's because I'm leaning on it or I'm gonna stop leaning on it. 4 3 0 0 0 0 3 9 0 0 0 0. Okay, right. I've done all of my areas, so I basically found the frequencies. I can now go across and read my questions. So use Danielle's histogram to answer the following questions. Circle the earliest decade in which anyone included in the histogram could have been born. So obviously we're going to look at the smaller number, the smaller one, so in 2001, because that'll be the earliest time people would be born. The oldest person could have been 90, could have been like 72, but according to the histogram it goes up to 90. So 2001, take away 90 is 1911. See, look, I've said it and I wrote it, but my pen hasn't. So that's obviously this category. So which one has 1911 in it? From Danielle's histogram, the population of under 50s in Wales was 1,870,000 in 2001. Calculate the increase in the population of under 50s from 2001 to 2011. So in 2001, In 2001, she's got 1870. Obviously, we want to then do 2011, so under 50. So the top one, you can check his if you want. So you want this one, and this one, that's 40 up to 50. So from 0 to 50, all these people here. So you just added all those up, you can check his, but it does work. Compared to 2011. So we want to add all of these ones up now. So the 72, the 40, 36, and 43. So we want to add all those up, and we should get 191000. So, that's not a 0, is it? So the difference is just 40,000. That's your answer. It seems easy because you've done the bit before where I said to. So 3 marks in the back. The 60 to 69 years saw the biggest increase in population from 2001 to 2011. Calculate the percentage increase in the number of 60 to 69 years from 2001 to 2011. So same as we did previously. So do the 60 to 69 years for 2001, do the 60 to 69 years for 2011, work out the difference, and we've got to do the percentage change. So the 60 to 69 year olds are, different colour, 60 to 69, they've got 300 and 380. So in 2001, it is 300. In 2011, so 10 years later, 380,000, sorry. So to work out your percentage change, or in this case percentage increase, we do your change, so the difference between your numbers, which is obviously 80, over the original. So obviously the 2001 figure, which is 300. Put that on your calculator, do 80,000 over 300,000, or 80 over 30, 80 over 300, sorry, which is 27%. Part B, the age group of 19 over. The data in this table is also available to Sanya. Explain why she did not include this in her histogram. So, yes, there are people over the age of 90. However, it says 90 and over. These are all about groups that end. Obviously, 90 and over doesn't end, so she wouldn't know what width to do her bar. So she won't know the width of the bar, because obviously it's 90 plus, so bars are groups. So the number of 40 to 49 year olds in 2011 was different to the number of 30 to 39 year olds in 2001. So these people are the same people, but in 2001 is different to 2011. So hopefully nobody's died. Let's hopefully the number goes up. So in 2001, the 30 to 39 or 40? I can't remember. 30 to 39 and 40 to 49. So 30 to 39. 410. It goes from 410 to 430. So it's gained people. Phew, no one's died. Well, you just want a reason why a population would gain people of that age. More people have obviously moved. So in 2001, it was 410, wasn't it? And then in 2011, it was 430. People, same people, just 10 years later. Obviously, more people. They've moved to Wales. Okay, question 8. Helid, I don't know, is the captain of a cargo ship. She is planning on her next. What's her woman's name? Is Helen? I don't know. Is planning her next voyage. She's been employed to deliver 3 times 10 to the power 5 tons of sand. So some standard form here. She needs to know the volume of the sand before the sand can be loaded onto the ship. She has been given the following information about sand. So the mass of a grain of sand is 1.2 times 10 to the minus 3 grams. Okay, but we're in tons, we're going to have to convert, aren't we? Volume of a grain of sand is 0.32 millimeters cubed. First one, calculate the number of grains of sand in 3 times 10 to the power 5 tons of sand. Right, you've got grams here and tons here. You need to convert them to the same. I'm just going to put the grams into tons. So you need to know that they're in. should know that there's 1,000 kilograms in 1 ton. There's also 1,000 grams in 1 kilogram. Therefore, there's going to be 1,000,000 grams in 1 ton. So before you divide these two numbers, you want to put this into tons. So take your 1.2 times 10 to the minus 3 and divide it by 1,000,000. Is that 1,000,000 or is that 10 million? 1, 2, 3, 1, 2, 3, yeah, it's 1,000,000. And you come out with 1.2, basically add in 6 more zeros, so it's minus 9. Then you can divide them. So obviously if she's got this, she can take this much sand, and each grain is with 1.2 times 10 to the power of minus 9. Just calculate the number of grains of sand in there is divide them, so 2.5 times 10 to the power of 14. Leave it all in standard form because it says give your answer in standard form. It also, if you put that on your calculator, make sure you put brackets around here. Otherwise, calculator might get confused. It shouldn't, but it might. Could be in a different mode. Next one, calculate the volume of the tons of sand in meters. Why? So this is in millimeters, and we want it in meters. So you need to know how many millimeters are in a meter. Well, you need to know how many millimeters cubed are in a meters cubed. So we did something similar in previous questions. So you should know that there's 1,000 millimeters in 1 meter. So you've got 10 in 1 centimeter and then 100 centimeters in 1 meter. There's 1,000 millimeters in 1 meter. So to work out 0.32 millimeters into meters cubed, you want to cube the thousands. You want to do 1,000 times 1,000 times 1,000, which is, I believe, a lot. Is 1,000 million? I don't know. So cube 1,000. And then divide 0.32 by it. So you're going to do 0.32 divided by 1,000 cubed to get it into meters, to find out the volume of grain of sand in meters. That is 3.2 times 10 to the minus 10 meters cubed. So if each grain of sand is that, and we've got 3 times 10 to the power of 5 tons of it, just want to times those two. So 3 times 10 to the power of 5, each one is 3.2 times 10 to the minus 10. Again, just bracket those, and you get, it's not given in standard form and doesn't ask for it in standard form, so you can leave it as an ordinary number, which is 80,000. Okay, next one. Helid has been given the following instructions for her voyage. From Port A, sail 200 kilometers due south of Port B. From Port B, sail due east of Port C. From Port C, sail on a bearing of 318 back to Port A. You basically draw a sketch, so you don't have to do it accurate, you just want a sketch. So she sails south for 200 kilometers at B. Then she goes east for a bit at doesn't know how long, and for Port C. From Port C, she sails on a bearing, so bearings are from your north line. She's going back to A. So all the way around up until you hit A is 318 degrees. We want to calculate the distance from Port C back to Port A, so we want to calculate that length here. It's another trigonometry question. They didn't necessarily need to give you that bearing there, but obviously we know east is on a bearing of 90 degrees. You could use 90 degrees if you wanted to. Or you could use this angle here, which you would find out by finding this angle here. You could do whatever you wanted. You could find that angle out. It's up to you. You could keep with 90 degrees. I wonder if it works with 90 degrees. Let's find out. I might do something completely wrong now, but oh well. No, let's not use 90 degrees. I'm not going to do that. So this angle here, up the top, obviously the back bearing. So take off 180 from 318, which is 138. So that's from 118, take away 180. then you can obviously find this angle is 42. So I'm going to use 42. Don't even care about the other one. It's obviously 48, but you don't even need it. So this is my hypotenuse. This is my adjacent now. And we are using, COA. O and H is obviously car, so we've got cos of my angle, which is 42, is A, which is 200, over H, which I've labelled as X on the bottom, so we can divide, so we can do 200 over cos of 42, that doesn't look like a 2, 200 divided by cos of 42 is 269. Okay. The last time the cargo ship was unloading sand in a port B, it took 3 cranes, 45 hours to unload 250,000 tons of sand. Port B now has 5 cranes. Probably got a bit more sand, does it? Yes. 300,000. Right, why have we got such big numbers? I'm just going to cross off some zeros just so I've got smaller numbers on my calculator. Can't be pressing all those zeros. We've got to obviously work out our time. In hours and minutes, we'll get to that in minutes. Right, so we had 3 cranes, 25, obviously 250 tons at 45 hours. That's obviously 5.4. But now we've got, what have we got now? We've got 30 over 5 cranes, and that will give me 32.4. So it will take them 32.4 hours. Now you can work out that in minutes and hours if you want to, or really easy, as soon as you've got this in your calculator, press the time key. So that looks like it's just above the ENG, so it's like a degree and then a couple of, it looks like that. So you should get 32 and 24 minutes. That doesn't look like 24, but 24 minutes. Question 9. The train manufacturers developed a new braking system. Velocity time graph shows the velocity of the train from when the new brakes are applied until it comes to rest. Estimate the train's deacceleration. So when you have to work out deacceleration or acceleration, you want to calculate the gradient. Obviously this is a curve, so we're going to draw a tangent. Gradient is obviously your change in y over your change in x. So we want the gradient at 60, so at here. So because that's a curve and it's obviously at a point, you want to get a tangent. This is not going to go well. Oh my gosh, that was not too bad actually. I've done this on the piece of paper earlier, so I might be able to give you an accurate reading. Pick any 2 points you want. A really easy point to pick is this one. And I am going to choose this one. It was a bit obscured on mine. I'll do the one that I've got on my iPad here though, if you're following on from me. I normally like to pick ones that are on one of these lines, just so it's easy numbers. So my change in my y's, so this is 20, this is 30. So my change in y is 10, so from 20 to 30 is 10. My change in x's, that's 60. Ooh, that's 60, and that looks smack bang on 45 to me. So that is 15. So as long as the examiner can see that you're doing this, that you're changing y over changing x, then that's fine. So that's obviously 0.66666, which I'm going to put as 0.67, and it's in meters per second, so it's meters per second squared. So as long as the examiner can see your tangent and your lines going across or down or whatever, that's fine. They'll give you the full marks. So if you've got 0.67 and the person over there has got 0.24 or something, as long as they can see that you've done it correctly, then that's fine. Okay. Calculate an estimate for the distance travelled by the train from the instant the brakes are applied until it comes to rest. So you must use 4 equal strips. So unfortunately you can't do this, but I'm just going to get rid of all of my workings on here. You want to split this into 4 equal strips. So I'm going to go 20, ruler. So I'm going to go 20, 40 and 60, so that's 4 equal strips, but obviously there's curves in there, so you want to change these into shapes you can work with. So I've got triangle, trapezium, trapezium, trapezium. Obviously let's do that a bit better. So we have our 4 equal strips. We have A, B, C and D. Now area of a trapezium is, so the front of your formula booklet is half top add bottom times your height, but yours are the other way around. So when you have your trapezium like this, this is A, this is B, and this is our height. So you want to do a half A plus B times height. I'm just going to work out the A's and B's of them all now. So that stops at, obviously stops at there. So I'm going to do 36. That's 34. That looks like 29. If you've got like 29.5, that's fine. And then that one is on smack bang on 20. So I'll do it on here instead of the other side so you can see what I'm doing. So A is obviously a half times A plus B, so the 36 plus the 34, and then times by this length here, which is 20. And you get 700. Yes, 700. This one, so B, you're obviously going to do a half times the 34 and the 29, so 34 plus 29 times by this length here, so 20 again, and you get 630. For C, you want to do a half times your 29 and your 20, so 29 plus 20 times it by this height here again, so 20. And you get 490. And for D, you've got a triangle, so it's just a half times your base, which is 20, times your height, which is also 20, which is 200. So to calculate the distance, you just do 700, add 630, add 490, add 200, and you get 2020. And it is in meters squared, so meters, not meters squared. Yeah, it is in meters squared. It's not its distance, it's meters, not meters squared. Don't listen to me. And explain how you could use the graph to gain a more accurate estimate of the distance travelled. Well, we only split that into 4. If you want it even more accurate, you would split it into more strips. So split into more strips. That doesn't look like the word strips. Still doesn't look like the word strips, but you get the idea. Okay, question 10. Gardeners can apply weed killer to large areas of land by using a spray gun. Weed killer is stored in a large bottle that gardeners carry on their backs, and they're filled with this. Okay, so it's a weed killer's gun. The base radius of the cone is 9, so that's the same as obviously the attached, so that's going to be the same. Height of the cylinder is 4 times height of the cone, so the cone is height h. Cylinder is 4 lots of h. A bottle has been designed so that the capacity of 10 litres. There's a lot of conversions in this paper, but you need to know, obviously these are in centimetres, so volume is centimetres cubed, so you need to know that 1 litre is 1,000 centimetres cubed, so therefore 10 litres is obviously times by 1,000, so 10,000 centimetres cubed, so the volume is 10,000. Calculate the height of the bottle. So obviously do the volume of both of them, make it equal 10,000 and find out h. So the volume of the cylinder, I'll just put the volume, it's not obviously W, so volume of cylinder is the area of the face, so pi r squared times our height, so pi r squared h. The volume of the cone, so this is at the front of your formula booklet, so if you just flip to the front, it's the same as a cylinder, so pi r squared h, but it's a third. So they assume that the cone is a third of a cylinder. So, volume of the cylinder, we've got pi times r squared. R is 9, so 9 squared. And the height of this is 4, lots of h, so don't forget that. So if I just need to add them, basically. And the cone is a third times pi times r squared, which is 9 times our height, which we don't have, which equals 10,000. You could literally just divide by everything now, and you'll end up with h. If you want to work them all out, so do pi times 9 squared times 4, that's fine. Or if you just want to do 10,000 divided by pi, divided by 9 squared, divided by 4, divided by a third, divided by pi, divided by 9 squared, that's also fine, whatever you want to do. I'll just lay it out for you. So pi times 9 squared times 4, and then stick a h on the end, is 1017.87. I'm just going to round all these two decimal places. So that is the volume of the cylinder, plus the volume of the cone. So I'm going to do a third times pi times 9 squared on my calculator, and then stick a h on the end, which is 84.8 h, which is still 10,000 centimeters cubed. Then I can add these together. So I've got that much h, add that much h, don't know what that equals. So 1017.87 plus 84.8 is 1102.67. H is 10,000. So to work out h, just 10,000 divided by the 1102, which is 9.0688. I'm going to round to 9 centimeters. So the h is 9. You need the height of the whole bottle, so you want 4h, add another h, that's 5h. So the height is obviously 5h, which is 5 lots of 9, which is 45. Wheat colour is poured into the bottle at a constant rate. The cone is full of wheat colour after 2 seconds, so at 2 here it's full. Bottle is full after 26, so 26 is also full. However, a cone doesn't fill the same rate, so don't use 2 straight lines. The cylinder does. A cone's like that. So obviously this fills quicker than this bit. So it would go really, really quick and then it start to slow. So that needs to be a curve there. So like go slower and then really, really quick. And then obviously a cylinder, just constant. So that can be a straight line then. So from joined up to there, you need to satisfy 3 rules. That's got to be a straight line, they've got to join, and that's got to be a curve.